Okay, today we're going to talk about MidNite Solar's pre-wired solutions for off-grid, battery-based grid tie, and AC coupled. I'm going to very lightly touch on off-grid. This is not, intended for off-grid, but I want to touch on it just lightly, and that'll give people a chance to get in here. I'm also being asked if we can provide a white paper on AC coupled solutions. I'm very knowledgeable about off-grid, but need to know more about AC coupled. Yeah, absolutely. We do intend on doing as much documentation as we can on that. Feel free to holler at Kim or I, later on. We can get you fixed up on that. Okay. So I am Ryan. I'm the technical support manager here at MidNite Solar. There's my email address, there's my phone number. You'll also notice the main phone number on the bottom of every slide. Feel free to call and ask for myself or for Kim or Tom or Robin. You can email me. As you can see, our emails are pretty straightforward. Ryan at MidNite Solar, Kim at MidNite Solar, Tom at MidNite Solar. We'll try to get you fixed up. So the first thing we need to know is what type of system do I need? You're going out to meet with the customer, and this is what you got to figure out. If you're going to add batteries to a system, it's basically three distinct types of systems. You have an off-grid system, a battery-based grid tie, or AC coupled. So off-grid is basically, just as it says, it's a standalone system. Will not sell back to the utility. It can use the utility to charge its batteries, but it will not sell back. It comes with different various inverters available for off-grid. Some of them will actually do both. Some are 120 only, some are 120/240. So again, I'm not going to spend hardly any time on off-grid. We can do a whole PowerPoint on that later. Grid tie-off battery backup. We're going to touch on this a fair amount because this goes hand in hand with AC coupled in my mind. Grid tie-off battery backup is great if it's a new system and you're going in and this is fresh, everything is new, and the customer wants backup to their grid tie. This makes a lot of sense. There's places where AC coupled makes sense, but for me, anything, 8, 10, 12 kilowatts of PV probably makes sense to do backup versus AC coupled. I know everybody has an opinion on that, but I'll just stick with that theory for now, and we can take questions on that later. The grid tie-off battery backup, it does sell to the utility grid. It will run your critical loads during grid failure. Some of the things you need to know when you're designing these systems is, do you need 120 or do you need 120/240? Some models will support generator input as well, so those are the things you need to ask when you're designing a battery-based grid tie system. And in a battery-based grid tie system, you need to have enough inverter to sell the PV you want to have. So if you want to have 10 kilowatts of PV, you need 10 kilowatts of grid tie inverter. In an off-grid system, it's not designed like that. The PV system is designed to replenish the batteries, but the inverter is designed around the customer's load. So it's a little bit different mentality, if you will. AC coupled. AC coupled is adding battery backup to a purely grid tie system. This does add some complexity to the system and is probably best suited for existing grid tie system as an add-on. What this does allows you to go out and sell a value-added product to your customer who has a grid tie system only and wants some backup. This is a nice solution for that. The AC coupled, it's a growing market segment, especially over here on the East Coast after Sandy come through. There's a huge push for AC coupled. A lot of people got solar systems, grid tie solar systems with no batteries, and they have no power when the grid goes down. And they want to do something about that. So AC coupled is a nice elegant solution for that for an existing system. Some of the downsides is it can be confusing and it can be complicated, and there's numerous ways to go with AC coupled. So one of the things we've done here at MidNite is tried to take most of the mystique out of the equation. We offer several different variations, and we also are here and available to answer questions at any time. So what is AC coupled is the first question. AC coupling is a controlled backfeed if you hooked up like a generator to the output of a Magnum inverter, you're going to blow up the inverter. The difference in AC coupling is it's a synchronized backfeed. AC couplings, a synchronized backfeed. The grid tie inverter basically shifts its frequency to match the battery-based inverter. Yeah, I don't know. Everybody still hearing me? Somebody just send me a question saying yes if you are. Okay, perfect. Yeah, GoToMeeting and GoToWebinar seems to be having a little bit of difficulty today. They've added a webcam function to it, and it seems to have caused some grief. I'm not using a webcam, but it does seem to have caused some grief. Anyways, so we'll go back. Just holler at me over there in the question pane if I start breaking up or I need to stop and do something. The grid tie inverter will shift its frequency to match the battery-based inverter before connecting, so that makes it okay to do. Basically, it's just like I say, it's going to synchronize to it and then lock on to it. So, what is AC coupled? What are your choices? Well, in North America, the typical choices we use are the SMA Sunny Island, the Outback FX, VFX, GFX, and GVFX and Radian, and the Magnum PAE series and the Snyder XW series. The Magnum PAE, we recommend that one solely because Magnum is saying that their PAE has frequency dithering, even though it's non-adjustable right now, so it doesn't do you any good. But they recommend the PAE for AC Cup, not their regular models. I do have a question that's asking what brand and models of pure grid tie inverters have you tested that work well with your AC coupled solution? Pretty much all of them. I mean, I don't want to say all of them. That's probably a poor statement, but there's really no reason they shouldn't. The N-phase works well. The Fronius is working well. There's just a pile of them that we have tested with, and we know that does work and works fairly well. The Sunny Boy, you know, just like I say, the big thing you have to look at in this is that your grid tie inverter manufacturer tends to be the one that balks on the warranty issues, which is kind of bizarre because the off-grid or battery-based inverter is the one that's going to take all the punishment here. It's the one running in reverse. It's the one that stands a chance of being overloaded and blown up if it's not installed correctly. But the grid tie guys don't. Some of them don't want to support it, and from my experience with an N-phase engineer, it's more to the fact that they don't want the phone call saying, hey, I've got a Magnum inverter hooked to my N-phase and the lights went out, what do I do? So they want the simple, easy road, and they don't want to support any, any kind of problem like this. So you check with your grid tie inverter manufacturer and see if it's going to void their warranty and enact accordingly. Some customers don't care, some do. So do definitely check into that. I'm also being asked if this presentation will be offered, as a slideshow or a PDF or a video. I do presently have it recording, so as long as GoToMeeting, participates, it will be up on YouTube after we're done as well. Can I explain frequency dithering? Yes. The frequency dithering, basically the battery-based inverter will change its output frequency from 60 hertz just ever so slightly, and because the UL 1741 tolerances of the grid tie inverter are so tight, that will knock them offline, so they'll quit charging the battery. Basically, like I say, and we'll touch a little bit more on this later, but a battery-based inverter running backwards is unregulated. So if it can frequency dither, it can knock the grid tie inverter offline so it does not overcharge the batteries. And like I say, I'll go way in depth on that in a minute here. I just got an email too. We got an email from Enphase yesterday saying that it would not void the warranty if I installed it correctly. I'll forward that to you later. Thank you for that, Will. I look forward to that. Can anyone other than Magnum do that? What frequency dithering, I assume Josh is asking, and actually Magnum doesn't do it as well as some of the others. Snyder, the XW, does it, and the Sunny Island is probably the most elegant. The Sunny Island actually will control a Sunny Boy by frequency dithering, so as it changes the frequency, it can back the Sunny Boy down. I'll get into that a little bit as well. So here we go with the Magnum and the Outback inverters. Their sense circuits that control the charging are on the AC input, not the output. Therefore, we cannot control the charging of the battery. So what has to happen is we have to be able to disconnect the grid tie on high battery voltage. So on the Magnum and the Outback, what we do is we use a solid state relay set to, with the voltage sensing device, either the router or the Outback inverter itself, to disconnect that on high battery voltage. One of the things that you'll hear a lot of, you'll get a lot of people saying, well, you really need three-stage charging. Now, my opinion on that anyways, and it's an opinion, so it's worth what you paid for it, but if you're doing AC coupled as an emergency backup system, three-stage charging amounts to a hill of beans because it's a rare occasion that you're in AC coupled. So the maintenance charging of the battery is done from the utility grid during grid up conditions. During grid down conditions, you're not worried at all about three-stage charging. Now, if you're doing a mini grid or a micro town or whatever you want to call it, using all this different stuff, then it might be a different scenario. Then I might lean towards something like the Sunny Island for sure, because it will frequency dither and do three-stage charging. So, but for emergency backup, any of these inverters are going to do just fine. I do have a question. If we've seen any issues with the frequency that the battery-based inverter is operating at, for example, 20 kilohertz from an Outback and the frequency that the grid inverter is operating at, we have not. The off-grid inverters do not seem to cause enough noise to cause any problem. Actually, it might be the other way around. A lot of grid-tie inverters are fairly noisy. We're starting to do a lot of investigating on those with the arc fault combiner box and stuff, and it's surprising how noisy some of they can be. So, we're not, but we're definitely keeping a running list of any problems our customers run into, and as of now, we have not found any. The only issue we have found so far is that the end-phase envoy being on the utility side of the Magnum can cause a little bit more problem reading the end-phase, which if anybody's played with the end-phase and the envoy, they know that's problematic at best. And, so basically we recommend getting the envoy as close to the end-phase as possible. Least noisy grid tie inverters, not really short point. Stay tuned for that one. Some are different, like the Fronius, for instance, has multiple cylinders, so as you start to load it up, it will switch on another cylinder, so it's more efficient, and when those cylinders come in, they can create a lot of noise. There's some interesting things there, but we'll definitely be publicizing some of that. Okay, let me move on to the next thing. Okay, so frequency dithering, the SMA and the Snyder actually use frequency shift or frequency dithering to knock the grid tie inverter offline. I was told this morning that the Snyder XW can frequency dither and control the Snyder GT. I don't remember what Snyder calls it now, but they're grid tie inverter anyways. I'm told those two work together just like the Sunny Island and the Sunny Boy. I have not been able to confirm that yet. I will do that. So if anybody knows that, feel free to chime in. If they don't, feel free to holler for my results when I get a hold of Snyder on that. But basically, they both do frequency dithering, so there's no external relay needed. There is one more caveat to that. I'm being asked to explain frequency dithering again. Basically, frequency dithering, like I said before, is the battery-based inverter changing the output frequency to take it outside of the acceptance of the grid tie inverter. Grid tie inverter, because of its UL 1741, has to have a very tight frequency, regulation. And if it sees a frequency change more than a certain percentage, it has to knock offline. So that's what these inverters are doing. Excuse me. Generators and AC coupled. This is another caveat. There's an issue with generators and AC coupled. There's a couple issues. The first issue being that there is, if you put an inverter, say you've got a XW inverter and you hook a generator up to AC2 and you're in an AC coupled mode, what happens when the relay closes because the generator started is you just hook the grid tie inverter to the generator. Typically this isn't an issue. Inverter generators are noisy enough, the grid tie inverter won't connect at all, but we follow the manufacturer's recommendations in the Snyder and back, and everybody recommends disconnecting the grid tie inverter when the generator is running. So that there has to be some provision for that. We do offer some manual transfer switches. We are going to offer an automatic transfer that will automatically open the grid tie inverter when the generator starts and automatically transfer the generator to the inverter instead of the utility grid. And that brings up the second caveat. Inverters like the Magnum, for instance, and the Outback FX and GVFX lines have a single input. And having a single input means the utility is already hooked there. So if you want to feed in a generator to them, you will need to transfer, you need to have a transfer switch. So those are the two caveats. If if your customer says, I've got a X many kilowatt grid tie system and I really want battery backup, boy, I really want an automatic generator start as well, then put the little flag up there and say, okay, I got to think about that one just a little bit more, because it's something that we can accommodate in a pre-wired system for you, but it does require us to know about that, and it is a few added pieces in the pre-wired system. The other thing I want to point out, the Outback G series, not the Radian, but the G series, does not play well with generators. So if you're looking at doing a AC coupled and you want to add generator support, you might want to look at the Radian, the Snyder, the Magnum, the SMA, but you might want to stay away from the G series. The other thing you want to look at too is some installers tend to add a few more watts of PV at the same time. So if you want to do that, you can add like an XW inverter, an Outback Radian, or an SMA Sunny Island and put a charge controller on it, and you can also add some DC coupled PV as grid tied at the same time, whereas with the Magnum you can't do that. And I did get confirmation from an attendee that the XW works the same frequency shift as the SMA, so that's great news. The GT inverter is quite popular as well, so for those of you that are going to visit a site and it has a Sunny Boy already installed, or it has a Xantrex GT inverter installed, or the new Snyder, the same as the GT, you may want to really take a hard look at the Sunny Island or the XW inverter respective, because those will play together much nicer. I do have a question too about input power based on the battery inverter, but I'm going to get to that in a minute, so I'll hold that one for now. So I think that covers the generator. I think we've beat that one to death. Like I say, feel free to holler if you do have any questions on that one. So now for the question of sizing. This is probably the most common question that we get. The big thing is the Outback, Magnum, and the Snyder have what we call a 1-to-1 ratio. So for every kilowatt of grid tie you have, you need a kilowatt of battery-based inverter. Now the SMA, on the other hand, does not have that ratio. They recommend a 2-to-1, but that's not a hard, fast ceiling, if you will. So you could push that limit if you needed to. The recommendation of 2-to-1 is because of their frequency delivering 3-stage charging. If you went like 3-to-1, that might not work well. It's not going to hurt anything, but it might not work as well. So with that in mind, when you go to visit your customer, what I do, the first thing I ask is, A, what do we need for a battery-based inverter? What do we want to run when the grid is down? What's our biggest load we want to start? We're kind of in off-grid mentality now. Okay, well pump. It's a 3/4 horse well pump. That's the biggest load. Everything else is incidental. A 4,000 watt Magnum is going to more than do that. So the second question we have to ask is, what is the grid tie system and how is it comprised? And the reason I ask that is the same customer that needs, say, a 4-kilowatt battery-based inverter that's as big as they need to run their loads, but they happen to have 6 kW of N-phase on the roof. Now, what you can do is you can tell your customer, okay, well, here's what we can do. We can take a string of N-phase, go straight to the utility grid, take 2 strings of N-phase and go to the Magnum inverter, and we've got you a more cost-effective AC coupled system, because we did not have to buy the second Magnum inverter because of the AC coupling part of it. But let's say that same customer has a 6 or 7 kW grid tie inverter, single inverter. Now you've got a little more question to ask, because now you can't just put that against a single Magnum. Excuse me. So now you're looking at, okay, it's 6 kilowatts, so now I can go to the Snyder XW. That's not much more money. That's what we'll do. Let's get to 8 kW. Then you got to start making some more decisions. One of the things that we're seeing done quite frequently is people are using a DC solid-state relay in the combiner box to drop one string under grid down condition. Say you've got a 6 or 7 kW grid tie system, 2 strings of PV. You take a solid-state relay, put one string through that relay, and into what we call a wall wart, like a plug-in transformer for like your cell phone or whatever you may plug in the wall, and it puts out DC, low voltage DC, and you wire that up to that solid-state relay and plug it into a utility-powered outlet. Now, when you goes down, the outlet, we do wiring diagrams for that. That one is that one we do have. Audio is garbled a little bit. Okay, we're back now. Cool. So some of the caveats on sizing, and like I say, it's not real intuitive at times, but you have to kind of put on your off-grid hat and you have to say, okay, well, what do we need for an inverter for starters to run their loads? And that's the other thing you're going to run into as the customer. You're going to say, well, what do you want to run? What do you want to back up? And they're going to say, well, everything. And you go say, okay, well, we can do that, but here's what's going to cost. So there has to be some stuff there that happens to make that system affordable and realistic, and that's where you're going to have to work with the customer and size that accordingly. I'm asking some questions about Sunny Island. I'm going to hold that one for a minute until we get to the, we're going to talk specifics about each inverter here in just a minute, so I will hold the Sunny Island questions until I get to that one. So now we'll talk about the specific inverters, and here we have the Outback FX series, be it the G series or the off-grid series. Basically, they are 120 volts each. They are either grid tie or off-grid, but not both, and they both AC couple. The grid tie models, the G series, does not play well with generators, just as an FYI. One of the benefits is they have smaller scale and expandable. Another benefit is they come in 12, 24, and 48 volt. So that allows you to configure the battery differently if you want to start out with a smaller battery bank or you just want a smaller battery bank. It's just a little more flexible, if you will. It is expandable up to 10 of these. So if you needed a 36 kilowatt AC coupled system, you could conceivably do 10 of the VFX 3648s. I would maybe say that at that point, if you need 36 kW, it makes sense to look at some of the other options. But in any event, we're more than happy to go over that with you. This is just a picture showing what would be either an off-grid or a battery-based grid tie quad stack of Outbacks, all pre-wired, as you see it, with the autoformer. Actually, if this was grid tie, it would have to be two independent systems because you can only stack two of the Outback G-series inverters in a grid tie scenario, and you cannot use the autoformer. So this one is predominantly off-grid, but it could be altered for grid tie. We have seen people do that. If we're doing, say, 4 Outbacks in a grid tie scenario, you would actually need 2 critical loads panels, 1 for each stack of 2. So again, that's why we talk about going to something a little more adapted to the need, if you will. And the Radian. The Radian does grid tie and off-grid all in one box. Supports AC. It is 120 and 240 in a single unit. It also has 2 AC inputs. The second one being for the generator I liked about earlier. This alleviates the need for the transfer switch between utility and generator, but you still need a way to disconnect grid tie system when generator is running. We do accommodate that because in the Radian for AC coupled, we do have to do a solid state relay to disconnect the grid tie, so we can as well disconnect that grid tie when the generator is running. So that can be done for you. We just need to know that at the time of the order. Some of the downside is it is 48 volts only, and it does require the relay for AC coupled. But on the upside, like I say, it is 8,000 watts and it is stackable. There's a picture of it, just showing it with the cover off and the dead front off, showing some of the wiring compartment, just showing you basically, this would be a battery-based grid tie or an off-grid scenario, but just showing you basically how easy it is to wire up. You know, bring the utility grid into a couple bus bars, bring the critical loads panel into a couple bus bars, bring the battery bank in with a couple battery cables, and you know, you're ready to go. Yeah, does Outback have a tentative date on AC coupling support? I'm not sure they do, Josh. I'm not sure where they're headed with. I mean, they don't mind if you use it for that, but as far as them actually supporting it and doing frequency dithering and stuff, I'm not really sure where they're going with that. I don't know. I think they're focusing their efforts a little differently right at the moment, but that would definitely be a question for them. I'm not sure on that one. And this is just showing a dual Radian pre-wired off-grid system. Well, it could be it could be grid tied as well. Now, I'm not sure where you find the 2 or 3 monster men to put that on the wall, but that actually was shipped as a single pre-wired unit, as you see it, with a 1,000-volt battery combiner at the bottom, and the 2 Radians, the 2 Radian E panel, 2 classics. What we're working on doing right now is actually split the back plate, E panels, inverters. So this could be wired, the combiner and the E panels could be all wired together, because that's where the complexity is. And then you hang that on the wall, and then you would hang the inverters on top of it and plug in the few wires into the inverters. So this can be done in several forms, if you will, from semi-pre-wired to fully pre-wired, depending on how much weight you want to lift up on the wall. Now let's touch on Magnum Energy. Yeah, I'm being asked if I can tell which inverters are outdoor rated, NEMA 3R, as you go along. None of them, if that helps. All the battery-based inverters are indoor rated. We do have a NEMA 3R enclosure that holds, like the XW inverter, it'll hold Radian and SMA, and I suppose it could hold a Magnum as well. And we also have a couple other enclosures that I'll show you in just a minute here for the Magnum, or for any of the inverters, for that matter. But the inverter itself is not outdoor rated, but we do have a solution, so don't fear. The Magnum, again, if you're using it in an off-grid scenario, you can get it in 120 or 120/240 models. But when we're AC coupling, we recommend only the PAE series, so that would be 120/240. They have various wattages available for the off-grid model, but again, in the PAE series, it's going to be the 40/24 or the 44/48. We prefer the 40/24 because what we do is we use the Magnum's router as a voltage-controlled switch to run a solid-state relay to disconnect the grid tie when the batteries get full. They are stackable, up to 4 Magnums in a stack. They are vented only, and I will touch briefly on that a little bit. The Outback G series, or the FX series, if you will, a sealed version. Not waterproof, but sealed. So they're a little more dust-proof. They're a little better in a saltwater environment, if you will. The Sunny Island is 90% sealed. They have a cooling tunnel through it, but it doesn't go through any of the electronics. So that may be important if you live in a saltwater-based environment. Do the battery-based inverters have the same kind of momentary surge capacity while AC coupling as they do while they're inverting? Yes, they would. Actually, that would be increased. So let's say you have a 4 kilowatt Magnum and you're in AC coupled grid down. If you turn on a big load at that moment, the grid tie inverter is also helping. So now you have the combination of the two, as long as you don't sag the frequency. If you sag the frequency, the voltage out of range, of course the grid tie is going to go offline, and then you're just on the off-grid inverter. But the long and short of it is, yes, you get the same benefit of the battery inverter as you would if it was in an off-grid scenario. The AC coupled Magnum, the other thing I want to point out is Magnum is off-grid only. So if you are doing a system where you want to add a little bit bigger battery-based inverter and do DC coupling on a few thousand watts of PV, you want to steer clear of the Magnum because it is off-grid only. It does AC couple just fine, but it will not sell to the grid. It will pass through to the grid when the relay is closed in an AC coupled scenario, but it will not sell to the grid. And the off-grid model is available in 12, 24, and 48. The AC coupled PAEs are in 24 and 48. Now, for those that were asking about outdoors, I don't have a picture of the XW box, but we do have that. We should be getting that on our price list rather soon. But here's an example of a Magnum in an outdoor rated box. So as you can see, it's a complete package. The only thing you would purchase and supply for this package is the 4 batteries. We give you the cables and everything in this package. It's ready for the Concord PVS 3050Ts, I think is the, if I'm using all the right letters there. But basically it's set up for 4 of those batteries as a 24 volts. Same thing we were looking at before, only it's in a battery box. So behind all those breakers, excuse me, there's a whole pile of bus bars, and they're all labeled, like grid tie input here, critical load panel here, utility grid here. And so it's real straightforward. Again, our goal is to have you just need a pair of wire strippers and a screwdriver to attach to this thing. The router will come all programmed for the Concord batteries. So basically all you have to do is install the batteries, set the date and time on the router, and do a function test, and you're ready to go. Here's a picture of it installed outside. This particular box was an actual installer-built system. This was not a pre-wired system, but this is kind of a unique scenario. The customer wanted more battery capacity, so you can see there's a plug in the door and there's some extra screws on the box. What he did is he bought another shelf, and he put another shelf in it and altered the location of the latch so that he could do, you know, extra batteries and have extra capacity. Now, we could have also put a second box beside this or behind this with more batteries in it as well. And we do have another outdoor box that holds 8D batteries. And I'm being asked if those are sealed batteries, and yes, you have to absolutely use AGMs or gels in this scenario that I'm showing here, because you do not want vented batteries, you know, venting gas up around the electronics for several reasons. But yes, these, anytime they're in the same package, they need to be, you know, sealed batteries. We'll talk about the XW a little bit. The XW, quite similar to the Radian in a way. It does grid tie or off-grid or AC coupled, all out of the same package. It's 12240 in a single unit. It has two AC inputs, second one being for generator, just like we talked about on the Radian. Where it ventures a little bit is the XW is available in three sizes, 4 kilowatt 24 volt model, and a 4.5 and a 6 kilowatt 48 volt model. So that allows you a little more flexibility. You know, if you've got a 4 kilowatt system out there and you just want to do, but you want the frequency dithering and you want the generator support, everything else, there's an option for that. You know, so there's, again, no one inverter is always the right choice, I guess would be the best way to say it. It's going to take a little time and thinking to pick the right one for every job, and every job's going to be a little different. What we're finding a lot of installers and distributors are doing is leaning towards offering certain packages. So here's package A, it's going to give you this many kilowatt hours of backup. Here's package B, it's going to give you this many. And then if you need to vary from that, you know, you can do that. But having some jumping off ground, if you will, to be able to tell your customer for X many thousands of dollars, here's what I can install, and here's what's going to do for you. And, you know, if you need to venture from that, we can. I'm being asked if I've ever seen any installations of an XW inverter AC coupled with solar edge grid tie inverters. I've not actually seen it, but I did talk to a customer the other day that was doing just that. I think it was an XW inverter. It may not have been an XW with the solar edge, though. I can't swear to that one. But the XW is a very popular inverter for AC coupling, and there's a couple pretty large companies that are doing hundreds. And so far, the only issue we've run into with one of them I've dealt with that's done probably 100 of these installs is a GFCI receptacle in the bathroom nuisance tripping off the Snyder inverter during a grid down scenario. And changing that to a different brand GFCI receptacle in the bathroom took the problem away. Also being asked, are most of the products that you are speaking on available in 230 volts AC 50 hertz grid tie AC coupled application? Yeah, if the inverter manufacturer makes a solution for 230 50 hertz, we absolutely pre-wire it, and most of these inverter manufacturers do make those solutions. Actually, I think all of them do. So yes, that's not a problem. Give us a shout, give Kim a shout, give myself a shout, or give Tom a shout. We'll fix you right up on that, answer all the questions on that. But if the inverter manufacturer makes it, we can pre-wire it. So now I'll move on to the Sunny Island. Undoubtedly probably one of the bigger topics here. So let's talk about the Sunny Island for a while. As you see it, the single Sunny Island system with the autoformer and the E-panel, just so you'll know what these boxes are. The very top box, the narrow one, is the autoformer. It's a custom autoformer we make using SMA's core, but our packaging. And our E-panel down bottom with all the disconnects and everything else in it. So some notes about the Sunny Island is it is grid tie or off-grid and AC coupled. It's 120 volt only, and it's a single input, but we do offer some solutions for that we'll talk about. It does come in 4.5 kilowatt and a 6 kilowatt unit. It is stackable up to 3 units in regular cluster. and it comes. Those are some of the goods or bads, if you will. Talking about the automatic transfer switch, we do have the Sunny Island has a little bit unique scenario for AC coupling because they have a digital logic input that tells them when they're in off-grid mode. And when they go to off-grid mode, they change parameters of the grid time inverter. It's Sunny boy, and they audio back. Okay, giving it a minute. I'm gonna come back. Okay, is it better now? Okay, they're telling me it's better now. So let's start back over on the Sunny Island. I don't know where it went bad, but I'll just start at the top. I'll clear up these questions just so I can see the fresh ones coming in. Okay, so the Sunny Island is a grid tie or off-grid inverter. It does support AC coupled. It's available in 120 volts only and a single input only, but we offer an automatic transfer switch solution. It is a 4.5 kilowatt or a 6 kilowatt unit. It is stackable up to 4 units in a cluster, and it is available in 48 volts only. So those are some of the goods and bads, if you will, about it. We do offer an automatic transfer switch for the Sunny Island for the generator. Matter of fact, it'll work for anybody's, but it was designed around the Sunny Island because it controls the digital logic into the Sunny Island to tell it it's in off-grid mode. The Sunny Island does some unique stuff where it actually tells the Sunny Boy inverter, we're in off-grid mode now, forget about UL 1741, widen your specs out, and here's what we're doing. And it'll just change its frequency ever so slightly to tell the Sunny Boy what to do and how much power to put out. And that's why I say if you need something like a microgrid where AC coupling is your norm every day, all day, the Sunny Island is a very elegant solution because it does offer 3-stage charging. One of the things about the single Sunny Island as you see it, as you remember from before, the Sunny Island does not suffer from the 1-to-1 ratio that we talk about. So now you've got a customer that has 12 or 14 kW of grid tie inverter out there, and they just need 5 or 6 kilowatts of backup. This single system, as you see it, will actually do that. The problem is the grid tie inverter is more powerful than the relay in the Sunny Island inverter itself physically. Not our E-panel, but the actual relay internally. So if you tried to push all 14 kW backwards to the Sunny Island during a normal grid up condition, you'll burn the relay up. Actually, the inverter will go offline and open the relay to save itself. So what we've done is we've built what we call the SMARB, the SMA relay board, and it goes in our E-panel. And what it does is it transfers the grid tie inverter from the AC output of the SMA during grid down to the AC input of the SMA during grid up. So when the grid is there, we're biasing the inverter directly and we're putting the grid tie right into the utility grid so it's not going through the relay. As soon as the grid fails, that relay switches over and we flawlessly go right into an AC coupled scenario. Another function of that relay board is, as you see this on right now, the single inverter, the autoformer is always in the loop making the 240 volts for the critical loads panel. So let's say you're in the city and your customer does not need 240 volts in their critical loads panel, they only need 120. You still need the autoformer because the grid tie inverter is 240. But what you can do is you can move a couple wires inside the onto the SMA relay board, and when the grid is up, it actually switches the autoformer off, so there's no idle loss on the autoformer. It's a very efficient toroid, but even so, it is a little bit of wattage. So that was a request we had from several distributors and stuff, so we added that function to the relay board, and we documented how you would make that change in the field if you want to switch out the autoformer. I got a question about whether the Sunny Island will work with N-phase. The Sunny Island will work fine if the N-phase. I'm not sure. I've heard people that are working with N-phase to get banks of their N-phase inverters frequency windows changed so that they may have, say, 5 banks or 3 banks of inverter. and as the battery gets full, the SMA will do frequency dithering, and it will knock off the first bank of the end phase, and then as it gets full even more, it'll knock off the second bank and so on. But that's on a case-by-case basis. I don't think end phase physically supports that out of the box. I think you have to have them change the windows of each bank individually. Something I'm not completely sure on. I do intend on trying to get much more up to date on the end phase. And has it been tested with the SMA micros? I understand it has. I have talked to Roy Dingen, Tristan, and all those guys over there, and they're saying that should be a streamlined, flawless scenario, just like it is with the Sunny Boy inverters. So this would be very as well. Again, if these a good place in the AC coupled market. If you've got a customer that just flat out is trying to pinch every penny he can, and he just needs 4 kW of backup, it's going to be pretty tough to beat the Magnum. But if you want to offer him, a real robust, long-lasting, high-quality system, it's going to be pretty hard to beat the SMA. Picture of the quad stack, or the cluster, as Roy would call it. And as you can see down on the bottom, we've got our 1,000 amp combiner, and then that feeds each SMA. This would come to you as 4 individual pre-wired systems, each inverter and E-panel. You'd hang them on the wall, and then you'd plumb them up to your battery combiner. There'll be bars everywhere labeled, AC1 from E-panel 2, AC2 from E-panel 3, or whatever. That would be very well labeled, but this is just such a large system it couldn't physically be 100% pre-wired. I want to touch on the battery combiner just a touch. It's 1,000 amp rated. It has space for up to 12 of our big breakers, anywhere from 125 up to 250, and basically it has a 1,000 amp shunt in it. It's just set up to do either combining of battery strings or decombining of a string of batteries to go to several inverters. So it's a nice universal box, and if there's any interest there, definitely get a hold of us, Kim or I or Tom, and we can answer your questions on that. So that brings me to the bottom of the discussion here. So now I'm hoping there's lots and lots of questions. I can't find any data sheets on the MidNite pre-wired AC coupled systems. Do they exist? We're working diligently to put spec sheets on our website. Let me close this, and I'll show you some of the stuff that's going on. We are working to put spec sheets up on our website. Unfortunately, right now there is none on the AC coupled, but the Magnum stuff is fully documented on their website. We're working on the SMA and the Radian right now, and the Xantrex will be coming immediately thereafter. So Kim has been the keeper of documentation, and she's been in charge of getting things up on our website. Something new we're trying at MidNite is we're trying not to put stuff on the price list before we're actually ready. So we want all of our ducks in a row, if you will. We don't want to, drag you guys out and say, well, we don't have the wiring diagram for that, or whatever the case may be. So we're not putting it up here until we have everything 100% documented, and that's been the holdup on the SMA and the Radian. The product is there and ready to go. The wiring diagrams are all done. The owner's manuals are being finished as we speak, and then we'll be doing photographs and getting them up on the price list. The Magnum, like I say, as you go with our products, there'll be dimensional drawings, instructional documentations, manuals. A lot do have spec sheets now, but unfortunately the pre-wires don't yet, and I've got to get busy on that. Back on page here, you can see just some of the stuff we have on. There's all the AC coupled Magnum solutions. We do have, like I say, the off-grid and the grid-tie battery backup solutions, which pretty much are a plug-and-play AC coupled scenario as well, except for you get to remove the charge controller and a couple things. When are the dual Sunny Island E-panels shipping? They are ready to ship now, except for the manual. Larry is finishing the manual. The wiring diagrams are done. The product is done. And so you want to lean on Kim on that one, and she'll keep you up to date on that. But they are ready to ship now. So I think I've got everybody's questions. SMA Sunny Island 120 volt only, so 2 Sunny Island 6 kilowatt with 6 kilowatt PV. I think we touched on that, Rick, but I guess I'll touch on it one more time. I forgot you had asked that question earlier. Basically, still Sunny Island being 6 kilowatt, but the fact that they're not limited to the 1-to-1 ratio, if the customer had 12 kW of grid tie inverter, you could actually use a 6 kilowatt Sunny Island single system to AC couple that. You wouldn't actually need, to do 2 unless the customer needed the capacity of 2. Again, another question, if you have more AC coupled inverter power than the battery-based inverter is rated at, and you use some DC load diversion with relays to knock out some solar, will the battery-based inverter handle a short overload charging into the batteries the same as while it is inverting? I am told no. I am told Magnum it's a hard limit, or you void the warranty and probably break the unit. I'm also told that by Snyder. So the rule of thumb that I have adopted is on the Radian, on the Outback, the Magnum, and the Snyder it's a hard 1-to-1 limit, so you need to account for that in another way. Again, like I say, maybe putting a relay in the combiner box to drop a string. If it's like an N-phase system, we can just put the right number of strings in there, different things like that. But definitely, I would obey the battery-based manufacturer's recommendations on that one. Lead times, okay, that's Kim. I'll unmute Kim here in just a minute since I roll through some of these questions. What are the warranties on these? Well, we offer a 5-year warranty on any of our product, and then of course the inverter manufacturer, the battery-based inverter manufacturer, honors their warranty. So if you're doing a Magnum or a Snyder or a Sunny Island or a Radian, the core inverter itself is going to fall under the inverter manufacturer's warranty. And that would be the same as it would be if it was used in any other scenario. But the product, the E-panel, the lightning resistors, everything else comes with the 5-year warranty to go with that. All right, I don't know if I've got any more questions. I think I'm going to unmute Kim. Keep typing questions if you've got them, and here you go, Kim.
Can you hear me?
I can.
Okay. I was on the phone with Eric last night. He's the actual keeper of the lead times, and I jotted down some real lead times that I'm going to shoot off to everybody today. And this is what I have right now for all of you that are on the webinar. 3 to 4 weeks on Radian and SMA E-panels, or SMA E-panels. The Radians are 10-day. We do have 50 in stock. I think we were waiting on a bus bar, and that's right from Eric. Prewired Systems, the single, we still are working on getting the autoformer through ETL, so there's a question mark there. Dual pre-wireds we should be able to do faster. He's given a 3 to 4 week lead time. And I think that's what I've got right now for updates. If anybody that's on this webinar has not been getting updates from me, please call me today, give me your email, and you will get on our list. And other than that, I just want to say thank you to Ryan. This was a great webinar. I learned something new every time I watch these webinars on AC coupled. There's a lot of little things you've got to get in your head to be able to do these, and for the sales guys to be able to try to figure out which systems are right for the customers. And like Ryan says, we'll try to help you out the best we can.
Yeah, it's definitely, it's not hard to get your head around once you once you've really got involved in it. I know for years AC coupled eluded me, and it was one of them things that I didn't need to know, so I tried to ignore it because I didn't want to try to get my head around it. But now that I've really dived into it as deep as I have, I realize that it's kind of off-grid on steroids, if you will. So a lot of the off-grid mentality can flow over to this. And that really helps when you have that in mind, because most of you can attest to, if you've ever been out to a customer's site to talk to them about purchasing their very first ever off-grid system. They've never had battery power. They've always had utility grid. A lot of those things roll over from one to the other, and so a lot of that helps. If you don't have a lot of battery-based experience, that's where you lean on the pre-wired solutions, and you lean on MidNite, and that's where you start getting some core packages, if you will. You know, we can do a single Sunny Island that will do this, and it'll give you this many kilowatt hours of battery power. And that will run a 100-watt light bulb for this many hours, or it'll run a 1,000-watt light bulb for this many hours. Give your customers examples, put it in perspective, you know, things like that. And like I say, again, don't be afraid to lean on us. I do have a question. Please send copy of slides. Shoot me an email, ryan@midnitesolar.com, and remind me of that, and we'll make this into a PDF and get them off, or I can send it as a PowerPoint. I will have the PDF, the PowerPoint, and hopefully the video up on the internet within probably 2 days. I'm supposed to fly to New York tomorrow for training, but by looking out my window, I'm questioning that. So, but yeah, definitely shoot me an email. I'll get you whatever you need on that. Being asked to, hey Kim, any further info on UPCs? Don't worry about answering it if not.
Well, yeah, I don't have the answer there yet. I know if we're going to start doing government type contracts, they do require the UPC codes. I've just heard, no, we're not doing it. It's a money issue, but I don't know exactly where we're at with that. I think we need to start maybe investigating a little bit. Here at MidNite, we kind of have to decide where we put our money, and we need to get extra money freed up for all of the new stuff we have on our tables right now. So we're looking into it. I guess I don't have a definite answer yet. I know it does have to do with the money involved with doing it, and I know it might make it more simple for all the distributors to be able to get it in your systems. They have a scanner code, I guess, per se. But as of right now, I don't really have an answer.
Okay. Keep bugging us. Feel free to bug Kim or I on that, or even Robin. You know, if it comes down to it and we've got it, we'll make it happen. The pre-wired system adds about a third of the cost of the inverter to the cost of the system. Is this purely a labor saver? Can go over the MidNite innovation here. I'm working the sales side. Yeah, I'm not sure about the third of the cost of the inverter to the cost of the system. I'm not sure I understand that part of it, but basically what happens here is you're going to pay a little bit of a value-added premium for a pre-wired system. And basically what that is it's the labor cost for us to pre-wire and test and package this as a whole unit. So when the installer gets on site, be it an installer that's just super busy or an installer that doesn't have a lot of battery-based experience, he's got a complete package that's already done, so he knows all he has to do is install the batteries and hook up some AC power here and there and there. And you know, so that's where the real savings probably comes in, is your on-time, you know, on-site time, if you will. As far as the package, if you was to purchase all the individual components, you would end up saving, you know, a few $100 typically on a single inverter system. And Kim can correct me if I'm wrong, but I think it runs probably in the $300 to $400 range for us to actually pre-wire, test, and package it. You know, so there may be a possibility for some savings there if you've got a staff and a couple of them are you know, pre-wirers. They like to do, you know, wiring and assembly, and you do it in your warehouse or whatever, then sure, you probably would want to buy the pieces. And in either way, we offer everything either way, so you know, don't be afraid to holler. And yeah, okay,
So
if you could go.
If I might.
Oh, go ahead.
I would say always bite the bullet and get one of the systems pre-wired first, so basically you can look at it, open the door, see how it's done. Even for our guys that know what they're doing, just on a simple single off-grid Magnum, it takes John about 4.5 hours, plus he has to test it. So I think you'll find that you'll go pretty long. It's kind of a wash, I think, what you're going to really save in labor to doing the pre-wires. I think it's almost a no-brainer. Just get her done. Your guys still have plenty of wiring to do into the panels out there. I think you'll, in the long run, if you do a cost breakdown, that the pre-wires will end up saving you money and saving money on your customer as well.
Yeah, and I'll echo that too. But I do know some installers that have you know, several employees, and at times those employees might need something to do. So there's, you know, you don't have to buy it pre-wired, I guess was my statement. So I've got a question of, if you could go either way, when would you choose AC coupling over DC coupling? Higher daytime loads? Question mark. For me, the core answer to that question is there an existing system in place? If there's an existing grid tie system in place, then AC coupling probably makes more sense. If there's not, I 99.9% of the time lean towards DC coupled, simply because it's going to be less complicated, less cumbersome, and it's going to be less costly for you. Because if you're doing, let's say, 5 kW of PV DC coupled, you need one charge controller at an $850 list price. If you're doing 5 kW of grid tie, now you need a 5 kW grid tie inverter, and you still need some disconnecting safety stuff on the battery-based inverter. So for my money, my defining line usually starts out with, is this a new installation or is the equipment already there? And where are we headed from there? Now, that being said, there are times where an AC coupled system can make sense, and especially in places where buildings are spread out. And you may have a building over here that's 500 feet away from the other building, and it's got 10 kW of PV on it, or you can put 10 kW of PV on it. Now you can do an AC inverter over there, tied into a loads panel over there, fed back over to a battery-based inverter at the other building, and if the loads are predominantly when the sun is out in that other building, they can run directly off the PV panels. The problem with that scenario is you still need to have the building over there fed with high enough capacity wire to handle its loads, because the loads will not always be only when the sun is out. If it's a cloudy day or a snowy day, you're not going to stop doing what you're doing. So again, I draw the line at new system or existing system, and I also tend to lean towards 10 or 15 kW or more before I really think about AC coupled on a new system. So there's that one. Let me, yeah, I'm being asked again for a copy of the presentation. Like I say, just email me, Ryan@midnitesolar.com. I will definitely get you that. I probably won't remember everybody asking for it here, so asking about the, go ahead.
You can find these up on the web on the home page. Up in the upper left-hand corner, we have our instructional videos, webinars. You can link to it up there. And I'm going to touch upon this to use that. Ryan's taken a lot of time. Ryan and Rob have worked really well on getting the instructional videos up. Anytime you have a tech support question, even before you can go, if you have a computer, you can go up there and just watch these little tutorials on the Classic or pretty much all of our product line, and you can go in there and look. And Ryan's done a really good job of just getting in there, and you can answer almost all your questions right off of those little tutorials that he's done. So right on the home page, right, if you could hit the home page at the top there.
I'm already there. Yep.
Okay.
Yeah. Down here is the category Kim was talking about. Yep.
Mm-hmm.
So basically, I'll back up for anybody that wasn't paying attention when I did that. MidNiteSolar.com, and then right here, the power time. You just click on the educational training videos, and it's, that will take us to that page. And Kim's right, and definitely, you know, we're also open to recommendations. So if you guys think there's a need for webinars or training videos or anything, you know, shoot Kim or I an email, and we will tailor something down that road. Along that same lines, I am being asked about, you know, when we'll be doing an off-grid webinar. I'm probably going to try to put something together for off-grid inverters / charge controllers. I'm thinking it's probably going to be at least 2 weeks before I can get that together, but keep an eye on our schedule on our homepage. I will take you there now. Here's a quick schedule over here on the right showing what's coming up immediately, and there's a full schedule right up here if you click on schedule, and that will take you to our full schedule. Keep an eye on that, and that will tell you what's up and coming, and, you know, shoot us emails, whatever the case may be.
I'll make sure that anything that's coming up, again, if you're on my email list or if you're not on my email list, give me your email and I'll shoot it to you. So I'll make sure that I'm trying to make sure all the appropriate people at all of the everybody who sells MidNite gets it, but everybody. I'm getting end users, installers, everybody on this list, so we get communication up here. This is my job, is to keep updates constantly coming with you all, so you don't have to always remember to call us, because that's my job, is to keep communication open.
All right, and Curtis has a question. Can we AC couple, can we do battery backup for an SMA SWE 2500? I'm not familiar with that inverter. I'm not sure if there's something different about that. If you can let me know, Curtis, what would be different about that versus the other ones. I would assume we could, but if you want to shoot me an email, I can definitely talk to SMA and get you a 100% accurate answer on that. Anything I'd be doing here would just be guessing. Do you integrate some of the SMA communications control devices such as a Sunny web box, power reducer box, meter connection? We should be able to. That should not be a problem. Again, that would be a request, basically give us a shout, tell us you need a quote a pre-wired AC coupled system and you need it to have, the Sunny web box and whatever, and we can definitely do that. We are a distributor of SMA product for pre-wireds, so therefore we have access to everything they make and can package that into our systems. And Chris is also asking, so greater than 8 kilowatt you recommend which system? If it's an 8 kilowatt grid tie system and it's a single 8 kW inverter, I would probably go with the Radian just because it's a one-to-one match, or a single Sunny Island. That's a good match, and I assume that's what you're talking about, or you may be asking about battery-based grid tie. In that case, if I wanted to do 8 kW of battery-based grid tie, I would probably do a Radian at this point, or a pair of 4,500 watt XWs. All personal opinions, and you know what those can be worth sometimes. Let me look down through these. So let's see. Okay, so the only other thing I got is a reminder, can you show us your outdoor solutions fields? And unfortunately, like I say, I do not have a picture of the new outdoor battery box, outdoor box for the XW. I do, however, have pictures of the outdoor 8D battery box and the outdoor D3R battery box. So let's go here, go to AC coupled, and we'll look at this one here. This is the outdoor, what we call the D3R battery box, and it's basically meant to hold, as you can see, 2 sets of batteries or electronics on the top, and you could put 2 or 3 of these side by side or back to back. We can pre-wire Magnum and Outback inside that, and then those are about the only 2 we can do just because of the space. We move into the new box. Let me find it over here. Battery enclosures. This box is much deeper. It's made for the 8D batteries. It's made to hold 4 of the 8D batteries, and it is stackable too high. So the picture is a little deceiving. The box is, fairly good size. And it's, like I say, it's about 2 feet deep, 26.25 inches to be exact. So as you could see, you could be pretty creative with this too, and it does have a spot for battery breaker and other breakers in the shelf. And you can put another box literally on top of this box. They're made to stack too high. How does SMA work with other brands of inverters? Basically what it's going to do in that case is the SMA Sunny Island is just going to frequency dither, and it's not going to get any response it's still going to get the same amount of power, and it's just going to dither to the point that it knocks the grid tie inverter offline. And then when the batteries drop back down, it will pull the frequency back down just that little bit, and the problem goes away. And now they've even done something interesting. If you've got a Sunny Island and Sunny Boy scenario, when they frequency dither to the high side to knock, to regulate the Sunny Boy, they keep track of that, and at night they frequency dither back the other way when the grid tie inverter is offline, so that in a 24-hour period your clocks are still at the right time. Because as many of you probably know, the clocks are based on the 60 hertz from the utility grid. So if you run at 60.5 hertz, your clock is going to run fast. So that if you back down to 59.5 at night, to back off, to account for that. So SMA has put smarts into the system. They definitely have probably been the leader in the AC coupled industry, if you will, as far as being at the forefront of the solutions in what they can do. Their biggest lacking has been the way to correctly do it with breakers and bypasses and stuff. They just have not had a good balance of system, if you will. So we're working diligently with SMA America to bring that all to you. So. And that's all of my questions at the moment. Anybody else got any questions? Okay, I think that answers everybody's questions. Again, definitely feel free to beat on Kim or I or Tom whenever you need us. Holler when you need us. We're here. And I want to thank everybody for coming today and look forward to doing more webinars for you in the future. Kim, you got anything else?